Now, distance between 2 points. The pair x comma y, this x comma y is called coordinate of point x and y. That is, if we write something like this, x before y, we call it coordinate of x and y. That is, point at which x and y meet in a rectangular coordinate. Where x and y meet, we write it like this, x comma y. Now let's consider this this graph. This is y-axis, this x-axis, this is y-axis. This is point A here, and this is point B. Point A is a point where S1 and Y1 meet, this place, where they join. I'll write it as S1, Y1. S2, Y2, where S2 and Y2 meet, I'll write it as S2, Y2. We know that the distance between these two places is S2 minus S1. For instance, if you have something like this, let's say I have 2 here and I have 5 here, the distance between these places, we know that it is 3. How did we get that? We said 5 minus 2. Likewise, the distance between these places is y2 minus y1, which is this. So from that place, this is a right angle triangle. So what can connect these together? I'll call this place AB. What can connect these 3 together is Pythagoras theorem. So I will now say that by Pythagoras theorem, which says that the square of the hypotenuse is equal to sum of squares of the 2 other sides. That is s2 minus s1 squared plus y2 minus y1 squared equal to ab squared. That is this square. So this is what we call distance between 2 points. If I make AB the square formula, I will say that it is square root of s2 minus s1 squared plus y2 minus y1 squared. So this is called distance, or we can write it like this. It's still the same thing. I can say it is s1 minus s2 squared plus y1 minus y2 squared. So this is what we call distance between 2 points. That is distance between 2 points A and B. A is where S1, Y1 meet, and B is where S2 and Y2 meet. So we use this formula for finding the distance between 2 points. That is distance between this place and this place. That is our aim, and that is our topic. Now let's take example on this. Now this is the example. The first, find the distance between these 2 points. This is A and B. So we first know is that this is S1, Y1. We take this as S2, Y2. And we can decide to take this as S1, Y1, S2, Y2. And then I will use the formula, which says the formula is S1 minus S2 squared plus Y1 minus Y2 squared, or vice versa. So that our answer will be, we just substitute what we have, S1 minus S2, 6 minus 3. That is 6 minus 3 squared plus Y1, which is minus 5, followed by minus Y2. Y2 is 2, all squared. Then our answer here is 3 squared, 6 minus 3. Minus 5 minus 2 is minus 7. But because of the square, to become plus. So we have plus 7 squared. So this is 7 squared is 49. 3 squared is 9. So 49 plus 9, that will give me 58. Then we can use our calculator to finish the rest. Now if I consider the second one, point P is this, point Q is 7, minus 1. Then I'll use the formula. I can change it to be S2 minus S1 squared is still the same thing, Y2 minus Y1 squared. This is our S2. This is our Y2, or you can see the other time I took this as my S1. So this is my S1, this is Y1. You can use it anyhow you like. You can decide to say that this one is S1, Y1. You get the same answer. Now, let's use the formula there. S2 minus S1. This is our S2. 7 minus s1. Our s1 is 1 all square plus y2. Our y2 is minus 1 followed by minus y1. Our y1 is here, which is 3 all squared. Then our answer there will be 7 minus this is 6 square plus minus 1 minus 3 is minus 4. Then we have square. Because of that square, the minus will be neglected. So that finally our answer will be equal to 6 square plus 4 square. This is 36 and this is 16. So 36 plus 16 will give me 52. Then we can use our calculator to finish the rest. So that is that about distance between 2 points. Now you can practice this and try this. If the distance between points this and this is 13, find A. We only need to use this formula. Our 13 is representing PQ now. Our A is our, this will be our S1. This is our Y1. This is S2. This is our Y2. So at the end of the day, if you finish it, you should be able to get A is equal to 4 or A is equal to minus 13. Now let's move to another example. Example 2. Show that these points, point P, Q, and R, are vertices of a right-angled triangle. To show that these are vertices of a right-angled triangle, we know that in a right-angled triangle, let's assume that this is the P, Q, and R. If they are vertices of a right-angled triangle, then they must satisfy Pythagoras theorem, which says PQ squared plus QR squared is equal to PR squared. What that simply means is that anytime we are asked to show that these points are vertices of a right angle triangle, what we only need to do is we pair them. That is, we pair PQ, we pair PR, and we pair QR. If you cannot show that sum of the two pairs is equal to the third one, then we have shown that they are vertices of a right angle triangle. Let's get on. Let me first pair PQ. PQ, our P. Now, let's pair PQ first. Our P is this and our Q is this. Then we use the formula for PQ. The formula is this. Q2, our Q2, S2, this is our S2. 7 minus S1. Our S1 is 8 all square plus Y2 minus Y1. Minus 3 minus Y1. Our Y1 is minus 10. So this will make it to be plus 10 all squared. 7 minus 1 minus 8 is minus 1. But because of the square, we have 1 square. While this one is 7 square. From this place, we observe that our answer is square root of 50. From that place, I can say that PQ square will be equal to 50. Let me take note. So I've paired PQ. Let me pair PR. Pairing PR. This is our P, this is our R. I'll still use this formula. S2 minus S1. 0 minus our S1 is 8. All square plus Y2, that is minus 4, minus Y1. Our Y1 is minus 10. So it will make this minus to be plus square. And that will be equal to minus 8 square is 64. While this is minus 6 square, that is 36. Plus 6 square, that is 36. Everything there is square root of 100. So I can now finalize that PR square is equal to 100. So let me say it's star 2. I have paired PQ, PR. Let me pair QR. So I'll use the formula which says S2 minus S1 square. So this is our S2, Y2. So our answer is 0 minus 7 squared plus Y2 is minus 4. Minus Y1. Our Y1 is this. That will become plus 3 squared. This is Minus 7 square will give me 49. Minus 4 plus 3 is 1. Then minus 1 square is 1, which is square root of 50. Then I can now say that QR square is equal to 50. You will now observe there that PQ squared plus QR squared is equal to PR squared. You know, PQ squared there is 50. QR square is 50, while PR square is 100. So this has shown that the 3 points are vertices of a right angle triangle, since it satisfies this Pythagoras theorem. So that's how to show that they are vertices of a right angle triangle, and that solves it. Next one is coordinate of midpoint. So the coordinate of midpoint of point A and B here is given as this. What we are saying is that, let's say we have point A here and point B here. We have this. Can we find the midpoint here? Knowing what A means and B means. So if A is S1, Y1, B is S2, Y2, then the coordinate of midpoint is given as this. So let's take example on this. Example 1. You can see I've given you second formula now, which you must write down and memorize. This is the question. Find the coordinate of midpoint of these 2 points. Let's take note that this is S1, Y1, S2, Y2. Then the midpoint, let me use M for it. The midpoint is S1 plus S2 over 2. This is our S1, that is 4 plus 10 over 2, comma, 4 minus, there's minus there, over 2, comma, this is minus 7, that is Y1 plus Y2, minus 7 minus 11 over 2. So that the answer here is minus 6 divided by 2, comma, minus 18 divided by 2. Finally, we will have minus 3 divided by, if we divide it, divide by minus 9. So that gives the solution to the question. Now, the second question. If the midpoint of this line, these two lines, the midpoint of the point joining these two is this, find the value of x and y. These are the points. I will write everything here to be my S1, everything to be my Y1. This one is S2, this is Y2. Then I will use the formula, which is M. M is given already to be 2, 4. Let me write it here as 2, 4 equal to, we use the formula, S1 plus S2 divided by 2. S1 plus S, this is our, everything here is our S1, that is this, plus S1 plus S2. This one is our S2 divided by 2, comma, Y1 plus Y2 divided by 2. 2y plus 3 is our Y1 plus Y2. This is our Y2. 2s minus 1 divided by 2. So from that place, we can quickly equate these two. That is, this one will go to this, and this one will go to this. So for the first one, 2 will be equal to this one, and this one will be s plus 2y divided by 2. The second one, which is 4, will be equal to, if you simplify this one, it will give me 2s plus 2y plus 2 divided by 2, that is 2s plus 2y. 3 minus 1, that is 2. Then we have this divided by 2. If you cross multiply, s will be, if you cross multiply, s plus 2y will be equal to 4. I will call it equation 1. And this one too, if you cross multiply, you are going to have 2s plus 2y plus 2 equal to, this is 8. Finally, if you take plus 2 to the other side, it will become minus 2. So that we are going to have, if you divide, let's divide both sides by 2. This is s plus y plus 1 is equal to 4. I have divided everything by 2. So that finally our answer will be s plus y is equal to 3. Because if you take this to the other side, this is equation 2. It has led to simultaneous equation. This is a simultaneous equation, but I expect you to have learned simultaneous equation. So that should be an assignment to you. But solving it, we have that s is 2, y is 1. So that is that about coordinate of midpoint. Now we have considered a case whereby you know that if you have point A here and point B here, if this is midpoint, definitely this whatever we have here will be equal to what we have here. Now let's now consider a case whereby if this is point A and point B, then another point is dividing this. Definitely what we have here will not be equal to what we have here. So in this case, we call this thing division of line segment. That has led us to what we call division of a line segment in a given ratio. Now, for internal division, we have what we call internal and external division. Now, for the internal division, let A and B be two given points, just like this. And let P be a point which divides this segment A and B internally. That is, let P be a point in this place. We know that this one will not be equal to this. So let's say that this is M, this is N. They will not be equal to each other. So that is why we said in the ratio M ratio N. Then we divide our P of S comma Y to be this S2M plus S1N over Mn and this. And for external division, we have this P of S comma Y equal to this. You can see the only difference is that this is minus, this is minus, and this is plus. They are the same thing, S2M, S1N. So it looks like that of division of it's like that of midpoint. If they are equal now, then I can say that this is 1, this is 1. So 1 plus 1 is 2. It will remain only S square, S2 and S1 here. So it will be the same thing as S2 plus S1 divided by 2. That is if they are equal. But if they are not equal, so we have it like this. So let's take an example on this. Let's take this example. Obtain the coordinate of point that divides the join of these 2 points in the ratio 2:5. Let us first know that our M ratio N is 2:5. That means our M is 2 and our N is 5. For internal division, we use the formula, which is P of S comma Y equal to this. And our point A is 1, 2. This is our S1, Y1. Point B is 3, 4. S2, Y2. So in that case, our point S comma Y, which is internal division point, will be M S2. Our M is 2. That is 2 into 3 plus N. We use the formula since we have it already. Just be substituting. Our N is 5. N S1 divided by M plus N, comma M Y2. That is 2, 4 plus N Y1, 5, 2 divided by 2 plus 7, M plus N. From that place, I can quickly finish it up. 2 times 3 is 6, 6 plus 5 is 11. This is 11 over 9, comma, this is 8. 2 times 4 is 8, 5 times 2 is 10. Then, sorry, this is 5. Sorry, this is 5. So that means we are going to have 7 here. Our N is 5, not 7. Comma, this is 18 over 7. So that's our answer. And for the second one, external division. For external division, the only difference is that this place is B minus. I'll follow the same thing. It's the same thing here, but it's just that what is here will be minus. So in that case, for external division, the answer will be 2 into 3 minus 5 into 1 over 2 minus 5, like that. Comma, this one too will be 2 into 4 minus 5 into 2 over 2 minus 5. But if question did not specify, just use internal division. That is most important. In this place, we have 2 times 6. 2 times 3 is 6 minus 5 over minus 3, comma, this one is 8 minus 10 over minus 3. So that our final answer will be equal to minus 1 over 3, comma 2 over 3. So that is that about that. Now, in what ratio, another example, what ratio is the joining of these 2 points divided by this point internally? That is, we are looking for ratio m such that this divides these 2 points. The first thing is we recall the formula for internal division. That is, now we are given 4, 4, 7, 7. This is s1 y1 s2 y2. So from that place, we have been given this already. A is it here. I'll put it like that. I'll substitute. Then we are going to have, this will be ms2, that is 7m. Our s2 is 7. ns1, our s1 is 4. That is 4n over m plus n, comma. So the same thing, we have 7m plus 4n over m plus n. So from that place, you observe that they are the same thing. So in that case, I can relate these together. I can say that 7m plus 4n over m plus n is equal to minus 1. Now, let's cross multiply. If you cross multiply, we are going to have 7 plus 4n equal to minus m minus n. From that place, I can say that 7m plus m, if this one comes here, will be equal to minus n. When this one comes here, minus 4n. So from that place, we are going to have 8m is equal to minus 5n. Now, let's bring this one to this place and take this to the other side. So that we are going to have m divided by n is equal to minus 5 divided by 8. M divided by n simply means m ratio n. And this one simply means minus 5 ratio 8. So this is the ratio. The ratio is minus 5 ratio 8. So this is required. Another one is area of triangle. We consider triangle that has vertices s1, y1, b, s2, y2, and c. You know that triangle has 3 sides and 3 vertices. I want to find the area of such triangle. The area of such triangle is given as, you know that normally area is half base times height, so this will be half into, area is given as this. This is the formula of finding area. So to find the area of a triangle given the vertices A, B, C, then we make use of this formula. We only need to memorize the formula. That is why I said you should be writing out these formulas, because this topic has a lot of formulas. Memorize these formulas, write them down and memorize them. Now let's take an example. We want to find the area of a triangle having these vertices. So let's first take note that this is S1, Y1, S2, Y2, and S3, Y3. So we use the formula there. Area is equal to half into, so let's use the formula. The formula will then be S1 is our S1. Just substitute using the formula. We have known what all this stands for inside in this place. Then let's substitute. So this is S1 into Y2 minus Y3. That is 3 minus 7 plus our S2 is 2. So our S2 into Y3 minus Y1. What's our Y3? These are Y3, 7 minus 6. And another one, S3, which is 4 into Y1 minus Y2. And Y1 minus Y2 will be 6. It's our Y1 minus 3. So from this place, we are going to have, this will give me minus 24. This one will give me 2. While this one will give me 12. Finally, if you add everything together, I should get half into minus 10. But because we are dealing with area, you neglect this minus. You neglect it. So you say that half into 10. You neglect it. So that our answer is equal to 5 unit. We don't know whether centimeter. We just put unit square there. Now from this area of a triangle, we have another interesting definition from this area of a triangle. What we call collinear points. We define this. 3 points are said to be collinear if the area of the triangle is 0. That is another definition of collinear point. If they say that collinear point simply means that points that lie on the same straight line. For example, if you have point A here and point B here, point C, all of them lie on the same line, on the same straight line. We say that these 3 points are collinear. But in terms of area of a triangle, we can define collinear points. We say that these 3 points are collinear if the area of the triangle is 0. And we should know it will be 0 because when we have a straight line, there's no way it can be equal to 0. Now let's take example. So that will be our example 2. Now example 2. Show that these points 1, 2, 3 are collinear. To show that they are collinear, we only need to show that the area of the triangle is 0. First take note that this is S1, Y1, S2, Y2, and then S3, Y3. Then we need to find the area of the triangle using the formula. This is the formula of the area of triangle. Then let's use what we have there, our S1. Our S1 is 1 into Y2 minus 1. When we look for Y2 minus Y1 there. And when we look for Y2, our Y2 is minus 1 minus Y3. Our Y3 is minus 9. S2 is 3 into Y3 minus Y1. Our Y3, that's our Y3, is our Y3. 9 minus 3. And the next one is S3, which is 3 into, S3 is minus 2, minus 2 into Y1 minus Y2. That's our Y1, this is our Y1. 3 minus, our Y2 is a minus 1, that will become plus 1. Here will become half into minus 1 minus this is minus 10. 3 minus this, 9 minus this is 6 times 3, 18. We know that this one is minus 2. 3 plus 1 is 4, minus times 2, that will be 8. So we should know that this one gives me 0. Since the area of the triangle is 0, then we say that the 3 points are collinear. Statement here, since the area of the triangle is 0, then the given points are collinear. So another formula of finding area of a triangle which involves determinant of a matrix is this: half into S1, Y1, S2, Y2, S3, Y3, 1, 1, 1. So this is another formula of finding, but this is the determinant of a matrix. But because we are not dealing with determinant, that is why I've given you this. But if you are using determinant of a matrix, this is another area, formula for finding area of a triangle of points or of vertices A, B, C, S1, Y1, S2, Y2, S3, Y3. Now, you can be given question to find area of let's say area of any polygon. You need to draw. For example, if I consider a rectangle, you can use area of triangle to do this. Let's say we are finding area of rectangle ABCD. We can divide it like this. We can divide this thing into triangles so that this one will be area of triangle ABC. This one will be area of triangle ACD. So we'll find you'll be given this point, this point, this point, this point. So when we find using the formula finding the area, finding this, we add it together to get our result. Let's say we are given something like this, pentagon. It's very easy for us. You divide it anyhow you like into different triangles. This is one triangle, this is another triangle here, and this is another triangle. And we use the formula of finding area to get this. We just need to add 1, 2, 3. These three triangles together to get our answer. So that is that about that. Another one is gradient of a line. If you have the gradient of a line joining points this and this is defined as this: delta y over delta s. We normally call it we can call it slope. So in calculus we say that the y ds. So it is defined as y2 minus y1 over s2 minus s1, or y1 minus y2 over s1 minus s2. What we are trying to say is this: if you have line s1 comma y1 here and line s2 comma y2, if they are saying that gradient of a line, consider the adjacent angle here. If you consider this one, tan of this angle is what we call gradient. M is tan theta, tan of this angle. And we know that this one will be y2 minus y1. This one is s2 minus s1, because this one is s2, this is s1. So M is the tan theta. If they say that gradient is the tan of this adjacent angle of these 2 points. But what is our tan theta? Tan theta simply means opposite over adjacent. That is y2 minus y1 over s2 minus s1. So this is what we call gradient of a line. Or we can say that it is y1 minus y2 over s1 minus s2. It's still the same thing. Now let's take example. Let's take this example. Find the gradient of the line joining this one, which is 6, 5 and 2, minus 7. Here is s1, y1, s2, y2. Gradient is always represented by m, and the formula is y2 minus y1 over s2 minus s1. Our y2 is minus 7, then followed by minus y1. Our y1 is 5 over 2, that is s2 is 2, minus x1. Our s1 is 6. Here will give me minus 12 over 2 minus 6 is minus 4, and that will give me 3. So that means the gradient of the line joining these 2 points is 3. Another one is 3, minus 4 and 6, 7 and 6, minus 7. Here is my s1, y1, s2, y2. So we can use the formula. You can use this one. We can say that y1 minus y2 over s1 minus s2. You know, here I used y2 minus y1 over s2 minus s. We can write it 2 like this. Now, what's our y1? Our y1 is minus 4 minus y2. Our y2 is 7. Minus 7. So it will become plus here. Divided by s1. Our s1 is 3 minus s2. Our s2 is minus 6. So that here will become 3 over 3 minus this is minus 3. So that my answer is equal to minus 1. In that case, the gradient of the line joining these 2 points is minus 1. Now we have some conditions under this gradient. The first one, let's consider angle between 2 lines. Angle between 2 lines. Let's consider we have line here and another line. This line here, it has gradient m1. This line here, it has gradient m2. We want to find angle here, that this angle between these 2 lines. And we can find it using the gradient. If you have known the gradient of this line and you have known the gradient of this line, then the angle between the 2 lines is given as tan theta equal to m1 minus m2 over 1 plus m1 m2, provided that m1 is greater than m2. This formula is obtained from this tan A plus tan B, which is tan A minus tan B, which is tan A minus tan B over 1 plus tan A tan B inside our compound angle. So if I make theta the subject of formula, theta will be arctan m1 minus m2 over 1 plus m1 m2. So this is distance, this is angle, this is formula of finding angle between two lines. Let's take example on this. Example 2. Find the angle between the line joining this and this. Between the lines joining these 2 points and these 2 points. For the first one, let's consider 3, 4 and 4, 2. So we need to find the gradient of this line. So I will say that m is equal to, we use this formula for gradient, y2 minus y1 over s2 minus s1. That is minus 2 over minus 4, minus 2 minus 4, that is y2 minus y1 over s2 minus s1 over 4 minus 1. So that my answer is minus 6 over 3, that is minus 2. Also the second one, 2 comma minus 1 and 1 comma 2. So I'll find the gradient again. The gradient is use the formula y2 minus y1, this minus this, 2 minus y1, these are y1 here, to become plus 1 over s2 minus s1, 1 minus 2, that is 3 over minus 1, that is minus 3. You observe that minus 2 is greater than minus 3, so I can say that my m1 is minus 2 and my m2 is minus 3. Then I can make use of this formula. The formula will be arctan m1 minus m2. What's our m1 there? Our m1 is minus 2 minus m2 minus our m2 is plus by minus 3 to become plus over 1 plus m1 m2, that is minus 2 minus 3. This is arctan, this plus this is 1 over 2 times 3 is 6 plus 1 7. So this is arctan 1 over 7. That is the angle between. You can finish it off using your calculator. You find arctan 1 over 7. So that is the angle between these two lines. This is one line, this is another line. So the angle between them will be arctan 1 over 7. Now let's consider condition for parallelism. For parallel, let us first recall that tan theta. Let's recall that tan theta is m1 minus m2 over 1 plus m1 m2. For parallel, that is, this is what we mean by parallel. That is, there will be no angle between them. In that case, theta will be equal to 0 for parallel. For parallel, so theta will be equal to 0 because there is no angle between them. These are parallel lines. So from this place, I'll put 0 times 0 is 0 equal to m1 minus m2 over 1 plus m1 m2. If you cross multiply, you see that m1 minus m2 is equal to 0. Therefore, m1 is equal to m2. What we are saying in essence is that if two lines having gradients m1 and m2 are given, then they are parallel if m1 is equal to m2. What we are saying in essence is that if two lines are parallel, then they have the same gradient. Then m1 and m2 are equal. So it's a condition. So anytime they say that two lines are parallel, you should always know that their gradients are equal. m1 is the gradient of the first line, m2 is the gradient of the second line. So this one has m1 This one has M2. Then they are equal. So we should take note. Another one is condition for parallel. Condition for perpendicularity. Now, for perpendicular lines, what do you mean by perpendicular lines? Something like this. You know, in perpendicular lines, the angle between them is 90 degrees. In perpendicular lines, I will now recall this formula. For perpendicular line, then I'll put theta to be 90, so that here we have tan 90 degree equal to m1 minus m2 over 1 plus m1 m2. But tan 90 is infinity. So this will give me infinity equal to m1 minus m2 over 1 plus m1 m2. Infinity is no number. If I want to turn this infinity to 0, I will interchange it like this. I will say 1 over infinity. If I interchange it like this one too will go up. Is equal to 1 plus m1 m2 over m1 minus m2. I have interchanged this again. But this 1 over infinity simply means 0. This will be equal to 0. 1 over infinity is 0. That is the reason I want to interchange, so that I can get 0 here. From this place, I can cross multiply. Then I will now say that my answer is equal to 1. This is equal to 0. If I cross multiply, making m1, m2 the same formula, we have minus 1. Or we can say that m1 is equal to minus m1, m2. What we are saying in essence is that if two lines are perpendicular like this, if two lines are perpendicular, the product of their gradient is equal to minus 1. Or the gradient of one will be equal to negative reciprocal of the second one. So that is what they are trying to say. So anytime we mention perpendicular lines, we mean the two gradients multiplying together will give me minus 1. Anytime we mention parallel, we mean that their gradients are equal. Now let's take an example on this. Example, verify if the following lines are parallel. Verify if the following lines are parallel or perpendicular or neither. We have one line here. These 2 points will determine a straight line. Another 2 points will determine a straight line. The first one, we know that when we're talking about parallel or perpendicular line, is talking about gradient. So we are still dealing with application of gradient here. So the first one, 6, 3. Let's find the gradient of this one. If we find the gradient of this one, we use the formula y2 minus y1 over s2 minus s1. Let me find the gradient of this. If I find the gradient of this to be 3 minus 4 over s2 minus s1, 6 minus 2. 3 minus 4 is minus 1. 6 minus 4 minus 2 is 4. Now, for the second one, let me find the gradient of this. Now, our gradient here is, use the formula y2 minus y1. That is 1 minus y1 is minus 3, making plus 3, over s2 minus s1. 2 minus 1. That is, that will give me 3 over 1, 4 over 1, which is 4. We now see that m1 is equal to minus 1 over 4. m2 is equal to 4. They are not equal. That means they are not parallel. But are they perpendicular? To show that they are perpendicular, let's find m1 times m2. That is minus 1 over 4 times 4. Our answer is minus 1. Therefore, these two lines are perpendicular to each other. Now, if you consider the second one, which is 4, minus 3, 2, 3, and 4, minus 2, and 4, minus 17. It's not 4. This is minus 1. Minus 1, not 4. Is minus 1, minus 2. Minus 1, minus 2. That is what is there. minus 1 and 4 comma minus 17. Now let's find the gradient. We use the formula y2 minus 1 over s2 minus s1. This is y2, 3 minus our y1 is this, divided by 2 minus 4. This is 6 divided by minus 2. This is minus 3. While this one is another m. Use the formula minus 2 minus 17 minus making plus this. That is y2 minus y1 over s2 minus 1. That is this. So that this one will be equal to minus 15 divided by 5. That is minus 3. You see that m1 is equal to m2. They are equal to minus 3. Therefore, these two lines are parallel. So these ones are perpendicular. And these ones are what? Parallel. So that is that about perpendicular and parallel lines. So the next one will now move to this line we are talking about. Let's find the equation and apply all these perpendicular and parallel there. So what I want you to gain here now is that if two lines are parallel, their gradients are equal. If two lines are perpendicular, product of their gradient is minus 1, or minus m1 is equal to minus 1 over m2. So good day, we'll meet in the next class.